Let's give problem number 5 a try. So, if we take a look at the spectrum, you can see right away that I don't have a carbonyl. So here's 1500, 1600, 1700. So I have no carbonyl stretching. So right away that eliminates compound number 4 because we don't have carbonyl stretching. So there we go. So now we've narrowed it down to 3 compounds. They all possess a hydroxyl. So there's a hydroxyl here, there's another one here, there's another one here. And that's evidenced by this big broad stretch here. So if we circle this big broad stretch, so this would be our OH stretch from our alcohol. So we know the compounds in alcohol. What else do we know? Well, you can see that we have this other peak right here. So I'm going to circle this. So it's around medium absorbance. And if I trace a line down, it comes to about here. So this is around 2100. I'll just put around 2100. Oops, 2100 reciprocal centimeters. So if you look at the table of absorbances that's provided in our textbook, you can see that that's an alkyne carbon-carbon stretch. So this is the result of a C triple bond C stretch. Okay, so that eliminates, or actually, that means that it's going to be either that means it's either going to be compound number 1 or compound number 3. Also, I just want to point out that compounds 2 and 4 both possess a nitrile in them. A nitrile, the C triple bond N, that should have an absorbance around 2250. So that would be at a higher wave number. So that would be to the left of here a little bit. And we don't see that, so I'm going to erase that blue arrow so we don't see. So no nitrile. So also put no C triple bond N at 2250. So we don't have that, so it can't be. Again, so that eliminates this compound and this compound here. So then it's a battle between compound 1 and compound 3. So there's 2 ways you could justify the compound is being compound 1. The first way would be doing a little bit of conjecture and saying, okay, well there must be an sp hybridized carbon-hydrogen bond, which comes around 3300. So you could say, well, I have 31, 32, 33. So maybe this line here, maybe that's from a carbon-hydrogen and SPCH stretch, okay? But I would say that's probably not the best way to do it. A better way to do it would be to examine the triple bond, the alkyne, in compound number 3. So if I look at this triple bond here, so I'll put a little thing here by the triple bond, and if I look at it, here I have a methyl group on one side and a methylene on the other side. And what that does is it makes it what's called pseudo-symmetric, in that it doesn't absorb the infrared light, and so it doesn't have a dipole because it's pseudo-symmetric in that it has a CH2 on one side and a CH3 on the other side. Therefore, since it doesn't absorb IR, we shouldn't see a signal at 2100 for the carbon-carbon triple bond. So that leaves us with one choice, which is compound number 1.